So a little bit about who I am. As you know, my name is Rick Davis. I'm a senior customer engineer with Microsoft. And what that means is I don't work internally. I'm out working with our customers, generally our largest enterprise customers. Everything from the very reactive, such as incident response or threat hunting, to the very proactive, where I teach workshops, I do assessments, help customers deploy products, design and architecture, all of these kind of things. Over my career, I've spent a tremendous amount of time with PKI. I probably spend about 30% of my time on it now. It's been as high as 75 and 80%. I have a hand in developing our workshops, our assessments, most of our proactive offerings around PKI. If you're on Twitter, you can find me at the Ratelin. There. With that said, even though I work for Microsoft, and I do like to mention it because cool company, they're not representing here. They didn't send me here. All the thoughts, opinions, bad jokes, sarcasm, that's all mine. So just like to call that out. All right, so why are we talking about PKI? Over the last year in particular, there's been a tremendous amount of press and new things happening. In relatively reverse order here, golden certificate attacks, new tools like Certified, the PKI init patches, vulnerabilities, if you will, and then tremendous work, certified pre-owned, that was put out, amazing paper if you haven't seen that. So all of these things are really great, really good research, really had a lot of organizations do a fire drill, but there was kind of the problem of putting the cart before the horse. So in all the time I've been working with PKI, I probably take a guess that I've seen about 600 or so different PKI implementations in about 20 years. And with all of that, I see a lot of the same problems over and over. And that's the purpose of this talk. I want to call out a couple of the most common security and operational issues that I see. Because all of these new things happening, they're really great, and they're really things that you should pay attention to and deal with. But if you haven't done the basic things, it's not going to help a whole lot. You're not going to get the ROI in that, and there's just better approaches. So that's really the goal here. I want to call out some of the big things that I see, things that are very actionable, things that anyone in an infrastructure or certainly a security role can go and look at and hopefully drive some change and improvement. So with that said, we'll start with just a little bit of kind of terminology around PKI, how a couple things work, just at a high level, just so we can level set everyone's knowledge, make sure we're on the same page. So if you look at a certificate in the GUI on a Windows system, it'll look like this. It's relatively straightforward. All of the data that's represented there you can see on the command line. And the same would be true in a Linux environment or just about any other system. So PKI is standards-based, so you're always going to see really the same fields and relatively the same structure. And a couple items that are going to be very important for our discussion today. The first is what we consider a subject or an identity. So a certificate has to be issued to something. After that, we have who issued that certificate, generally certificate authority. And then finally, a lifetime of the certificate. So when a certificate gets issued, by default, it's going to have some time range baked in of when it's valid from and when it's valid until. So keep these elements in mind because we're going to talk more about these as we go. Another big item that we'll talk around is what's called a CRL, a certificate revocation list. So even though a certificate has a lifetime, it can be revoked, meaning an administrator can mark it as not to be trusted, not to be used, before it would naturally expire. So the idea is, let's say I issue a certificate to a server, and that certificate is good for a year. But 2 months later, for whatever reason, that server needs to be decommissioned and it's no longer used. I shouldn't let that certificate live another 10 months. I should revoke that certificate. Just good care and feeding of the environment. Now, a lot of times that doesn't happen, but it should. The CRLs have to be somewhere where clients can get to them. And that's what we're illustrating here. One of the fields in every certificate instructs the client where to go to get that CRL when it's checking a certificate. So when we think about checking a certificate, what happens? A couple key items. First, we do a subject verification. So if I go to www.microsoft.com, I'm going to get presented a certificate in the browser. And that certificate has to be issued to www.microsoft.com or an acceptable wildcard. And if it's not, I'm going to get a warning. Now, the browser's kind of a special case because I am going to get a warning, and like any user, I'm just going to click OK, and it's going to keep going. But most things that use a certificate happen programmatically. So any failure stops something from happening. But there's always that subject check. We always make sure that verification is correct. And then we check the time. So is today's date and time between that valid from and valid to field? So very quick checks that happen right off the bat. And then there's that big revocation check. So we'll talk a little bit more about this. This is a really big deal. This is one of the biggest reasons that PKIs go down and outages with enterprises that relate to PKIs go down. The revocation information is very important. Regardless of the structure and the size of your PKI, every certificate authority has to be creating these CRLs. And clients have to go and get them, and they have to check anytime a certificate is used to see if it's been revoked. Even if I checked 10 minutes ago, it might have been revoked 8 minutes ago. And there's some differences in how that's configured. The timing, how often they're issued, how clients can cache them. There's a lot of complexity there. But one way or another, clients have to feel that they've done that check according to the rules of the system and make sure that the certificate hasn't been revoked. Okay, just got brighter. All right, so I would argue CRLs then are the most important part of a PKI. I've been at large organizations and I've seen CRLs fail. Either they become unavailable, someone drops a network rule or changes permissions to where they're supposed to live, any of those kind of things. CRLs going down or being unavailable for a couple hours, I've seen cost enterprises hundreds of millions of dollars. So most organizations, if you have an internal PKI, it's a critical piece of the infrastructure, just like email, just like domain services. But most organizations don't treat it that way. So when there's a problem, it's big. If the CRL itself is expired, certificates will fail by design. Because if I need to trust the certificate, I need to know if it's been revoked. But if I can't check to see if it's been revoked, I'm not going to trust the certificate. I would much rather not trust a certificate that may still be valid and trustworthy than possibly accept one that's been revoked, because PKI is a system of trust. In addition to that, if you can't find the CRLs, same thing. It's the same thing as them not being there. If the CRLs are misnamed, misconfigured in any way, if it does not match up to what the client expects when they go to do that check, that certificate's going to fail. So these CRLs are incredibly important. So that brings us to the biggest problem that I see out there, operational issues around these CRLs. So the CDP is the CRL distribution point. So if we think back a few slides to that screen clip of a certificate and it had that locations of CRLs, that's what the CDP is. So the CDP is the set of locations where clients can go and get these CRLs. And ideally, there is a lot to it. It's not just one file server somewhere, and hopefully it's not any actual file server. So when you look at that list, you've got a number of different options. These options get configured at the CA level. So if you have a number of different CAs, you're going to configure all of these per CA. Some of the things that you might consider is how long the CRL is going to live, different types of CRLs, and where the CRL lives specifically. There's a lot of options. It could be sent over an HTTP protocol on an IIS system or something similar. It can be stored in Active Directory, so an LDAP location. In some cases, it can be a file system, an FTP, all of these other things. The key with this is we don't want points of failure. And a lot of times PKIs get built by someone following a guide online and clicking next, 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 next. And yeah, that works. You're going to have a CA and it's going to issue certificates, but when things go wrong, they're going to go really wrong. Generally, for design and architecture of a PKI, for an average organization, is probably 6 months of work. And it's whiteboarding, it's discussions with different teams. You can script out and build a whole PKI in 5 or 10 minutes, but you need all of that good design work to get this right. So that's our problem. The problem is there are points of failure within these locations. So more specifically, what do we see and what can we do about them? So one is out-of-band movement of the CRL files. So every CA has to make these files. And what they should be doing is the CA should be configured to write the files directly where they're supposed to go, directly to wherever the clients expect to go and find them. So those IIS boxes or the LDAP locations or whatever that happens to be. A lot of times I don't see that happening. We see clients write the file just to the local file system, and then they use some script or other process to move that file where it needs to go. Generally a bad idea. And why is that? So the CAs do a really good job of letting you know when something's going wrong, if you look for that. But if you're now relying on something out of band, the CA doesn't know that. If you tell the CA, just write it to the local file system, because then you're going to move it, well, it does that, it does its job, and it thinks everything is happy. It doesn't actually know if that file gets there. So you're introducing more things that go wrong. You could have a script now that could break, something with permissions on that script, or the location, or in really bad cases, that script gets hijacked by an attacker or some other process, and it becomes a way to escalate privilege. So all of this adds complexity that didn't need to be there, because the CA already knows how to do this. It knows how to write the file. So this is a big problem. We see this a lot, and this shouldn't happen. The CA should be writing the file where it needs to go. In addition to that, we see this concept of really kind of putting all of your eggs in one basket. So even though the CA itself could actually host these CRLs, so you can run IIS on a CA, but you shouldn't. Again, points of failure. So if I have a separate server that hosts my CRLs and my CA goes down, I do have some problems. So obviously if that CA is down, I can't issue new certificates. I can't revoke certificates. I can't renew any certificates. But my CRLs are somewhere out there safe, likely with a lifetime of days or more. So any certificate that's still out there works just fine. So I haven't really taken the enterprise down. But if I put everything on the CA, now if the CA goes down, I've lost everything. So within PKI, there's a number of different roles and ancillary services that you might use outside of the certificate authority itself. And the recommendation is generally to separate all of those roles. They all have a vastly different attack surface, different ports and protocols you might need, different places in the enterprise, different parts of a tier model, so they should all be separated for that reason. As far as the PKI is concerned, you separate that out to avoid these points of failure. Poor location design is probably the most important thing to consider, and this is a little bit harder to wrap your head around. So when we say location design, it's the location where these CRLs live. There's a lot of different types, and there's a lot of places where redundancy doesn't get noticed. We want redundancy within a location type and between a location type. When you configure these at the CA, you configure them as a list. It's an ordered list. The client parses them specifically in the list as they're defined, and this order matters. So think about this for a second. Let's say that I'm using two kinds of locations. I'm storing my CRLs on a web server, and I'm storing my CRLs in Active Directory, so an LDAP location. And let's say I have the LDAP location listed first. So what happens if I have a client on the domain and tries to get the CRL? So hopefully everything is great for them because they're on the domain, Domain controllers talk with everything, they converge very quickly. So that client is really happy, they're able to get to those CRLs. But what happens if I have a Linux device or a mobile device, something that can't or that I won't allow to bind to LDAP to get that information? So what happens in that case is eventually it's going to time out. And there are some values built in for that. In this list of CRL locations, by default, you get 20 seconds for a timeout. And it's separated out by the number of locations in that list. So the first location in that list will wait up to 10 seconds for a timeout. And then it's half the remaining time of that maximum. So with a 20-second maximum by default, you get 10 seconds for the first location, 5 seconds for the next, 2.5 seconds, and so on. Now, most cases, this check happens very, very quickly, and clients cache this information based on the configuration. So if everyone was waiting 10 seconds for every CRL check, the internet would grind to a halt. But it's a maximum wait time. So if I have something that can't talk to Active Directory, it might be able to figure that out very quickly, or potentially it could wait that maximum timeout. Not a good experience. But there's a bigger problem with that. If my two locations were LDAP and a web server, if that LDAP location is not available for some group of clients, in effect, I've designed in a point of failure. I've designed in a lack of redundancy, because now the only place those clients can go to are my web servers. And if they go down or they become unavailable, I don't have anything else. So having an LDAP location and an HTTP location gives me redundancy between those locations. And LDAP itself provides redundancy within its location. But that HTTP location on its own is a problem. So a lot of times, organizations will make multiple HTTP clusters. And this is a big point in design and architecture, usually one of the biggest decisions that you'll face. So we can do some things to make it better right off the bat. We can make multiple IIS boxes, put them behind a VIP and a load balancer, but we still have that one URL that we're hitting. So we can use GTM and LTM technologies if we have other data centers or we're leveraging the cloud. But more than likely, we're still going to want multiple groupings of these systems, in effect, multiple locations. So when I say HTTP, it's important to note we're not talking about a website that you're going to go to, even though that can be made available. It's not the intention. We're simply using the HTTP protocol to pass data around, because it's very firewall and proxy friendly, it's easy to monitor, and every system, every operating system, embedded devices, everything knows how to deal with HTTP. So this is one of the big problems with these locations. A big decision point is, do we even use LDAP at all? 7 and 10 years ago, we wouldn't even ask the question. Everyone was using it. It made a lot of sense. Now, in the last 3 to 5 years, I see fewer and fewer new implementations of PKI using an LDAP location. Just for that reason, because everything can use an HTTP location, not everything can use an LDAP location. Now, if you have a large PKI, and you have some CAs that you know are only issuing to domain-based users and systems, then it makes a lot of sense to use that location. And that can be something that you think about as well. Because all of these settings are specific to a CA, one of the reasons that you might have multiple CAs are to change these kind of configurations based on the clients that they're serving. But it is a tremendously big decision point. And then we have that overall lack of redundancy. So regardless of the locations that I use, regardless of what I design, you have to think through, are there enough options? And this is a tough question because you're never going to feel like you really came up with a good answer. There's really no cookie cutter approach with PKI. It's very dependent on the needs that you have, the kind of certificates you want to issue, the design of your architecture in general, and a lot of other things go into that. So what's right for organization 1 will certainly not be right for number 2 or 3 or whatever. I've been doing this for decades, and I regularly see new things, new designs that just weren't appropriate anywhere else, and maybe I won't see it again. So there's so much design and architecture work that has to go into doing this right for your organization. But regardless of what's there, you should be able to take a look and have a little bit of a thought experiment and figure out, well, if this goes down, what else can the client do? If this location goes down, what else can the client do? Do I have more than one location? So things that you can think through. You don't necessarily need privileges on the PKI or the CAs to see these kind of settings because they're baked into the certificates. Now, hopefully, you have some of this documented, not only the settings, but the reasoning behind why it was done the way it was done. And if no one can answer that, it's time to maybe have some more design work and discussions around it. So, as good as you can be with the design and the architecture, at the end of the day, you've got locations that exist outside of the PKI itself. So we rely on these IIS boxes or LDAP. So that means that forces outside of the PKI can wreck your CRLs as well. A network change that blocks access to these locations, a permissions change on where you're storing the files, a DNS change to one of the VIPs. You know, it's never DNS, so that couldn't happen, but all of these things outside of the control of the PKI, and probably the PKI team isn't really looking for it, but you want to be looking for it. You need a way to monitor that. So either getting that visibility to the PKI team or a NOC or a SOC, depending on what your organization has. So you want a way to know from the outside, from the client's perspective, you know, is everything look normal? Is everything still accessible? All right. So then switching gears a little bit. That's the big operational side. We'll talk about a big item on the security side. And for the most part, it's privilege and permissions. And it's really important. CAs specifically, but really the PKI as a whole, is probably the next most important thing after your domain controllers. By that I mean, if an attacker compromises a CA, they're going to own everything as if they compromised a domain controller. More than that, it's going to be very hard to notice. Most PKI is kind of treated like a black box a little bit. It seems like magic to a lot of people. People don't know it very well, but attackers know it. With all the new research and tools, there's a lot of ways. So PKI and certificate authorities are what we would consider a tier 0 resource, just like ADFS or an AD Connect or the domain controllers. If an attacker hits one, you're done. Most organizations don't treat it that way, or when they do, they don't do their due diligence following all the paths to the CA like they would with a domain controller. So having some of these rogue permissions and weird privilege is an easy escalation path for an attacker, but it can be hard to manage. Every CA is basically its own little island. So you need a way to monitor not only the CAs, but other things like templates that I'll talk about here as well. You need some process, you need policy, you need documentation, you need monitoring. And there's really nothing out of the box to do these things. You've probably already done these things with other applications and critical services in the environment, but more times than not, PKI gets left out. So we want you to start doing that with the PKI. So let's start with a template. What is a template? So templates is a construct of Windows server-based PKI, domain services-based PKI. So Microsoft didn't invent PKI. We follow the .509 standard for the most part. But templates is primarily a Windows construct. And it's a way to rapidly issue certificates, and in a lot of cases, without any real user input or impact. So without templates, if I want a certificate, I have to supply all of the information that the CA needs to build it. Specific fields in a specific order, in specific syntax, tens and tens, possibly hundreds of different items that have to be just right. At worst, it won't get issued and it'll error out. Or in really odd cases, it will get issued and weird things will happen. So it was very, very difficult. But in a template, I can configure all of those things as an administrator, and then I can get all of my users, cookie-cutted certificates, or all of my SQL servers, or all of my domain controllers, very specific use cases that I can control. So these are set once in the environment, and then I load these templates wherever I want the CAs to service them. But the templates start with a lot of permissions. Take a look at a few of them. You see in those little checkboxes what we see. There's not a lot of variance. There's not a lot of off-the-wall options there. They're pretty straightforward. We can read, meaning we can use command line, we can go in a GUI tool, and we can see that the template is listed. Enroll allows us to do a manual enrollment process. Auto-enrollment means with something like a GPO, I can turn that on to work with a template, and without anyone's input or impact, I can issue certificates to anything domain joined. But there's a few other items there, and they're a problem. So write and full control, there's no reason that gets given out. There should never, well, 99% of the time, there should never be a write privilege given. It just doesn't make sense. Full control will happen. By default, the last administrator that made a change to the template is going to have the full control rights, or it might be the person who created the template. But that should only be an administrator. So there's a lot of stuff that needs cleanup there as well. First, think about just overly broad rights. I see this a lot. So if you look in this, the second item from the bottom, just above enterprise admins, says domain computers. So that was probably a default in this template. And domain computers means every computer, every server, literally everything in the domain will have whatever those rights are if I were to click on that. Well, if I'm only issuing certificates off this template to certain systems, Windows 10 devices, SQL servers, Exchange servers, something, then domain computers is a bit too broad. And a lot of people don't trim that down, and it absolutely should be. Any write and full control permissions definitely should be looked at. And this is something that you should be alerting on, auditing regularly, and just have good care and feeding in the environment. A lot of defaults are there, and they're really bloat. They're really there to get started. For example, domain admins and enterprise admins. By default, they have rights on every single template. Generally, those people are not your CA admins. The people who are my experts in PKI, they're probably not my experts in domain services. Now, there might be some crossover there, and there may be reason to use them, but it's probably not everyone in that group. So it's very common to have a separate group for PKI admin and strip some of that out. In either case, likely enterprise admins doesn't need to be there regardless. And it'll be a little different per template based on your architecture, based on your organization, but all of these should be reviewed. I guarantee everyone I would find at least one item of bloat if I looked through templates that you had in an environment. With the templates aside, now let's think about the CAs. The CAs have their own set of permissions, just like templates do, and we see a lot of the same problems, but now it has much more impact. So on the templates, on the CAs themselves, just looking here at a clip of the GUI, just like a normal security tab, a normal ACL that we have here, but we just have a few options. So manage CA, it's basically the service administrator for the CA. They can change configuration, they can stop services, they can revoke certificates, they can back up things, they can change things, they can really do anything they want. Issue and manage would be a right that you would delegate out if you had someone that needed to work with certificates, to approve requests, to revoke certificates, but you don't want them being the service administrator. So with that, again, we see bloat. We see a lot of the defaults there. Again, domain admins, enterprise admins, they probably don't need to be there. In some cases, there are other things that fall in based on the template that you're using, based on how you configure the CA. Over time, this is going to change as well. PKIs are generally living for decades in an environment, sometimes more. So if you have something that got built 5 years ago or 10 years ago, you've probably gone through different naming structure of your groups, organizational changes. So you probably have groups that aren't right anymore, people that don't exist in the organization anymore, and you're just not catching it. So it's important that, again, this gets audited, this gets monitored. Service accounts are big. So having a service account with privilege at the CA level is pretty dangerous. Now, there are certainly reasons to do it, but you think about where the CAs fit in that structure. Again, tier 0, critical resources, just like a domain controller. So now, if I have a service account that's an administrator on a CA, now follow that attack path. Wherever that a service account goes, whatever application or servers that it's a part of, now that there's an attack path from there to my critical systems. That also means that likely all the administrators of that application are in that attack path. So a very, very broad stroke here. So putting service accounts, accounts for other applications at the CA level is something that you have to be very careful about. Now, I'm not saying don't do it. There's absolutely reasons to do that. Things like mobile device management tools, they'll need exactly this. But when you do this, you have to be aware of what's happening. Perhaps even build your structure so there's a separate CA with only that function. So if there is a breach, if there is an attacker, if something goes wrong or doesn't behave well, you can just cut that off without impacting the larger organization. Enrollment agents are the big case for things like service accounts. So an enrollment agent is something that can get a certificate on behalf of someone else. Also very dangerous. So if I could do that, I'm going to ask for a certificate in the name of your CFO, or a certificate for my computer in the name of one of your domain controllers. So dangerous. There's reason to do that, but when you're allowing this kind of behavior, again, tightly controlled and monitored. Most organizations don't have any of that, and we regularly see attackers abusing exactly this kind of escalation path. By and large, local groups and bloat of administrators on any Windows server is generally a problem for organizations, but absolutely no place for it on a CA. Should absolutely be turning the knobs on that, bringing that down to the bare minimum. An extension to this now with the security issues, what happens when powerful certificates become available? And there's just a couple categories of this that I'm going to mention. One is that if you allow the CA to accept input from a user when they're requesting a certificate, like I just mentioned, I'll request a certificate in the name of your CFO. If as a user I could put in anything I want, that's an issue. So we say that in that case, the CA is allowing enrollee-supplied information in the request. Certainly a reason to do that in certain cases, but for most cases, there's not. So if and when you are allowing that, it needs to be monitored. Things should not get automatically issued in those cases. Administrators should be checking that request. Templates for very powerful systems, like domain controllers. You should be very clear on what's getting issued and when. There should never be mistakes where a domain controller certificate lands on some other server, or a code signing certificate goes to a random user. Anything that's powerful like that should be very carefully controlled. And then SAN names. It's an interesting topic. So a SAN name, a subject alternative name, it's basically an alias. So I will issue a certificate to a subject, so maybe my name. So I have a certificate literally issued to Rick Davis. But I have a SAN configured, and it's my email address. So things like that can happen. They can be configured for whatever you want. There are applications and services that require very specific SAN names be entered. So there's a real reason to use them. But again, if I can put in anything I want, that becomes a security risk. So the use of SAN names is really hard to catch. There's not a lot of good monitoring for that. So it comes down to the hygiene of the CAs and your administrators. And at the end of the day, for all of these things, monitoring, alerting is incredibly important. I kind of beat the dead horse with that because just about everyone fails at that initially. Once someone realizes, hey, we need to do better with our PKI, we want to start looking at it. It's not until that point that they realize we don't really have any monitoring, any auditing, any alerting. We don't really know what's going on, even if you have dedicated staff for it. So closing some of this out, have an assessment of your PKI. I'm not trying to sell you one. There's plenty of places that have them. There's even free ones that you can get online, scripted and through other services, but get one. Just get an idea of where things stand. Whoever you have responsible for PKI, whether it's a dedicated team or person, get them some formal training. There's a lot of good resources out there, both free and paid. Level set. If you've got someone that's been doing it a long time, I guarantee there's new stuff they don't know about. If they've not been doing it a long time, there's a steep learning curve and there's stuff they should know. And then finally, if you have a PKI, it's probably critical for your organization. And unfortunately, you're probably not treating it that way. So it should be part of your DR plan. It should be tested. It should be just as important as things like domain controllers and SharePoint and email, because if those things are using certificates and your certificates fail, it's a big problem. So that's all I had for you. Hopefully you're able to take some of this information back, take a look at what you have, and push for some improvement. I'll be around for most of the day. If you have questions, track me down. I love to talk PKI. Shoot me a message on Twitter, whatever that happens to be, and hope you enjoy the rest of the conference.